Today we're going to learn about Gaussian elimination. Okay, we are going to solve this system of equations right here. We've actually solved it before, but we're going to do it again using matrices. So let's set up a matrix first. Now the way this works is we take all of the coefficients of each equation. So we're going to have 1, -2, 3, 9. Next row will be -1, 3, 0, -4, and last row looks just like that. Now we want to do the same thing that we did before when we were solving three variable systems. We want to get that stair formation going. We want to put this into row echelon form. So we need this to be a 0, this to be a 0, and this to be a 0. We'll worry about the leading ones after we create our zeros. So let's start by eliminating that -1. So we rewrite the rows we are leaving alone. And in order to eliminate this -1, we can add that to the first row or the third row. I'm going to go with the first row because 1 minus 1 gives us that 0 without us having to multiply anything. So we're going to add these two rows together. So here we go. We've got 1 and -1, that's our 0. -2 and 3, that's just 1. 3 and 0 is 3. And then 9 minus 4 gives us 5. Okay, we've got our first 0. We need to find our second, or create our second. So we're going to make that 2 a 0. We can use the first row, but we've got to multiply it by -2 first. So we're going to multiply by -2 and then add to the third. So I'm going to rewrite these two rows. And here we go. -2 times 1 is -2 plus 2 is 0. -2 times -2 is 4, minus 5 is -1. -2 times 3 is -6, minus 5 is -1. And last one, -2 times 9 is -18, plus 17 is another -1. So now let's work on making this a 0 right here. And then we'll have our little triangle of zeros. So we can eliminate this -1 by adding the second row and the third row. So I'm going to start back up here. I'm going to have 1, -2, 3, 9. And the third row will be replaced again. So we've got 0 plus 0, that's just 0. 1 and -1, 0 again. 3 and -1 is 2. And then we just have 5 plus -1 is 4. Okay, we are almost in row echelon form. We've got our zeros here, but we need leading ones. We've got a leading one in the first row, a leading one in the second row, but we need a leading one in the third row. So the way we do that is we can multiply the third row by 1/2. And now we've got 1, -2, 3, 9, 0, 1, 3, 5, and 0, 0. 1/2 times 2 is 1, and 1/2 times 4 is 2. So here is our matrix in row echelon form. Now all we have to do is rewrite our equations and back substitute. So that first row, these are the coefficients, 1, -2, 3, and 9. So it would be 1x minus 2y plus 3z equals 9. Then we've got 0x, 1y, 3z, and a 5. So 0x, 1y, a 3z, 5, and then the last equation will just be z equals 2. So we know z equals 2, we can substitute, and we get y equals -1. So x minus 2 times -1 plus 3 times 2 equals 9. That's a 9. Plus 2 plus 6. So x equals 1. So our solution is 1, -1, 2. So to solve a system of equations using Gaussian elimination, you're going to first write your system as a matrix using the coefficients and the constant. You'll write your matrix in row echelon form, and you do this by creating that triangle of zeros. You're using the techniques of elimination that you've learned before, that is multiplying rows by constants or adding rows together. Then once you have row echelon form, you're going to rewrite your matrix as a system of equations. You back substitute and then write your solution.